And hello, welcome everyone to this video. So in this video, I just like to explore some ideas I'm interested in. I guess it's for personal fun and stuff like that, but I don't know. It's just for fun that I do this kind of videos. So today's question, or rather today's idea I'm exploring is about plastic. Yeah, so plastic. As you can see, my YouTube search bar is here. Um, If you go to Pexels, you can find a lot of royalty-free images of plastics, and this is often the image that shows up. Okay, all of these are royalty-free. I can thank the contributors here. So, yeah, plastic is problematic. We have it accumulating in our landfills. It's in oceans and stuff. It's not good for the environment. We get that picture, and we want to do something about it. And worse still, even the even the recycled plastic is sent elsewhere. Okay, uh, where might it be sent? Okay, if for example, plastic from the United States is actually sent to places like Malaysia and the Philippines. You can actually check out these two videos, which I'm going to put into this link in the description. It's in a GitHub Markdown document, which you can explore online. I have a GitHub repository where I'm going to store all of this stuff. I call it engineering can or not. Okay, can or not is a Singaporean phrase, or Singlish or Manglish. Some people in Malaysia do will speak like that too. This is a Singlish phrase which it's our local way of speaking, and we are trying to ask the question, is this idea feasible? Okay, so you can read more on the README once I update this repository. And yeah, basically going to explore some of these ideas. So yeah, like I said, the problem with plastic is that yeah, a lot of it's accumulating in the oceans. So I'm just going to draw a little bit of an ocean here. Don't mind me, I'm not going to be very professional about this. This is just for fun. I'm making this video for fun and entertainment. So yeah, we have a lot of plastics in the ocean. You just draw one little bottle here. And yeah, from land it is going into the ocean, and we're not doing very much about it. Okay, so yeah, from land it's going into oceans. From more developed countries, when we collect recycled plastic for recycling, it is often being sent to less developed countries in Southeast Asia, such as Malaysia and the Philippines, where they're burning. They could be burning, or they can be sitting in landfills and not really being recycled. So it's a problem, right? So as a Chinese proverb, or I don't know where it comes from. On Google, it says that the Chinese proverb is it's better to light a candle than curse the darkness. So yeah, we'll do just that right here. Okay, there are two ideas which have caught my attention. Okay, they are caught my attention here. First one is a very famous famous, I guess, a viral video kind of a thing. So basically, when we construct roads, okay, I'm just going to draw maybe using a white dotted line. Yeah, get it as white as you can. Okay, and yeah, we have roads. Okay, normally what we do is that we like to use bitumen. Okay, bitumen is the sticky part of crude oil. So so I don't know what color should we use for crude oil, because we have a black background. Yeah, black background we cannot really use for crude oil, because it's already black. Like crude oil is black in color. So I'm just going to try to use something like blue, even though blue is more the color of water. But yeah, I guess this will have to do, right? This is crude oil. Again, pardon the coloring and the unprofessional things. It's just I'm doing this for fun. It's not really for professional presentation. So crude oil, what is it distilled into? Okay, crude oil is actually a mixture of many things. The bottom one yeah, one of the fractions of crude oil. So crude oil has a mixture of many hydrocarbons, the lightest of which you have things like methane, a very potent greenhouse gas, and yet it is very useful for running natural gas power plants, things like that. They'll probably use it in the refinery for furnaces or perhaps some other purpose. I do not know. Okay, you have C2 to maybe C4, propanes to butanes. Okay, this is the liquefied petroleum gas, LPG. LPG. All right, this is pretty good stuff. Then you have the gasoline. Okay, C5 to maybe C7, C8. I do not know. Okay, you got gasoline or petrol. Okay, gasoline. Then you have the diesel, which I'm not going to even bother drawing anymore. Diesel, kerosene, so on and so forth. Okay, as you go down the distillation column of the crude oil, as you split it up, it gets heavier and heavier and stickier. Bitumen is sometimes used, sometimes you can use it for, I guess you can turn it into coke, it's carbon, or you can actually use it as a binder for roads. And as I've seen online, basically watching Thunderfoot's videos. Okay, Thunderfoot, where's Thunderfoot's videos? Oh dear, did I close it? Okay, let me bring it back up. Yes, and this is the video I wanted to show. This is called Plastic Road Waste Busted, which kind of is an opinion where, a very well researched opinion, I guess, that using plastics for road construction may not be the best idea. But we'll explore why. Okay, but from his video, he did quote a fact or quote a statistic that 5% of the road is bitumen, roughly 95% is gravel or stone. Okay, so you use this bitumen, the sticky stuff, as a binder, and you crush rock and you lay the top of the roads with it. Of course, there's a lot more to constructing roads than just the top layer, but the top layer is what gets the most attention. So for now, I'll just simplify this, or just keep my discussion to the top layer of road. All right, so again, 95% of roads is gravel. That's why it's hard, it grips, and bitumen is the stuff that binds it together. Okay, there was this idea that I think Thunderfoot was exploring and refuting, that instead of using this mixture of bitumen and crushed rock or stone, you use plastic to do this. And the gist of the video, as you saw, okay, you use plastic to pave the road. Okay, may not be a good idea. Okay, if you use 100% plastic, it may not be a good idea. Okay, that's why you have this title, Plastic Road Waste Busted. You can go and check his videos out a little bit more. Okay, so this is sure bowl, or cannot. Okay, we can't do it. Okay, or you can give this a sure bowl rating. In Singapore, we like to use this phrase sure bowl to express doubt and skepticism as to whether an idea is truly feasible. Okay, so I will say this, this one may not work. Okay, so I'll say the same. Say this, sure bowl. Yeah. Okay, so that is the deal with 100% plastic roads. That is not feasible. Why? Because one thing is that it's a little bit, one thing I was discussed in the video is that it's too soft. Okay, it cannot handle the weight of cars. It doesn't grip surfaces well enough, especially when conditions on the road get icy. Then you'll tend to lose grip easily, and that's a safety hazard. You cannot have that happen. So this is probably not feasible. A perhaps more feasible idea is that instead of using this bitumen in crude oil, you replace this bitumen with a binder that is derived from plastic. So we don't take this 5% from bitumen, we take it from the plastic waste. Okay, so this was determined to be somewhat more feasible, and there are people actually doing it. Okay, so I think this little video by CBS Mornings, it does say that there's some Scottish company called okay, let me take a look at that. Okay, so the so-called company that was described in this video, where was it? Here. In this video by CBS Morning is this company called MacReber. Okay, I don't know how to pronounce it, but I'll just call it MacReber. If you know how to pronounce it, correct me. Yes, so this is it. Let me unblock some of this. Yes, MacReber products are made from non-recyclable plastic waste that were destined for landfill or incineration. It's the end of the road for plastics. So that's the one that they describe the problem. They describe their solution here, and they want to sell you the solution, or whoever, you know. Okay, so by extending part of bitumen in the mix, by extending part of the bitumen in the mix, MacReber products reduce fossil fuel usage, leading to reduction in carbon footprint and helping to foster a circular economy. Pardon the dark mode here, so the color themes don't really work well, but that's what they are about. They are using the plastics likely. They are using the plastics likely to act as a binder. Okay, act as a binder to, well, over here it says enhance the asphalt use. Okay, asphalt is another name for bitumen. So asphalt is another name for bitumen. Okay, asphalt. So they may or may not be reducing this 5%, 100%, but they're throwing this plastic into the 5%. So maybe it's like 1 or 2% plastic. I do not know the exact proportions, so don't quote me on it. But that seems like a more feasible idea, and there are people actually doing it. And since there's a company here, there are people actually, I guess, making a business out of it and providing jobs. So seems pretty okay. This idea, I would say, maybe can. Yeah, maybe can. So it maybe can, we like to say in Singapore, it may work, you know. So that's the expression I like to use. Maybe can, or sure can. Yeah, since if these guys are making money, then sure can. This is a can-do idea, an idea that works. Okay, so I guess that concludes the part about roads, which I can actually talk about I can actually put the links in later. For me, I'll just put it in now, and I'll close all the tabs in the browser. Okay, so companies like MacReber, they might have contributed to this solution. Well, reducing plastic waste. So instead of developed countries sending the so-called recyclable plastic to Malaysia and Philippines, you know, they sent so many from, I think in 2020, that Malaysia actually sent some of these containers back, according to this South China Morning Post video. Right, so instead of doing that, put it into the roads. That's one solution. Okay, again, that also begs the question, how much plastic can the roads take? Is there enough demand, or is there enough supply? Okay, and then is it enough to reduce all the existing stockpiles of plastic that already exists within these landfills? All right, so and how fast then can we get the road building companies or the government to really use this sort of method? Okay, so yeah, that all depends. A lot of people have governments have different philosophies. Some really like their like to make money. Some really care, well, at least care or appear to care more about the environment, right? So that's another question for another time. I'm more interested in the engineering solutions and the aspects, so I'll just move on to the next bit. Okay, one thing I was thinking about was the use of plastics perhaps in smelting ore. Okay, how does smelting work and what does it do for you? Okay, Smelting is the process of turning iron ores into steel. Okay, at least that's one example of smelting. That smelting doesn't just mean iron ore exclusively, but the basic reactions are like so. You might iron ore from the ground, which is usually in this form, iron oxide, and of course there will be some impurities there, like clay, silica, whatever. Okay, but the crucial thing that gets the iron out for the steel is this iron oxide. Okay, so we need to find a way of getting this iron separated from the oxygen. So this is iron 3 oxide, which actually is rust. Okay, we need to get the oxygens out. How do you get the oxygens out? Okay, the traditional way is to use some sort of carbon. So iron 3 oxide plus some 3 carbons. Okay, this carbon can come in the form of coke, which is a very pure form of carbon. So what they do is that I think they take coal and then they bake it until there's nothing left but carbon. Something to that effect. Or is it asphalt as well? Okay, asphalt, they can do that. They take the bitumen and then they heat it up to get rid of all the hydrogen stuff or all the moisture, and it's essentially left with mostly carbon. Okay, mostly carbon. Right, of course there are other impurities there as well, which I will not discuss here for simplicity. What happens is usually we'll just get the iron out, which is a liquid form, and this thing is actually 1000 degrees or more. Okay, this is very, very hot. Then you will have maybe 3 molecules of carbon monoxide. And then you might say, what do we do with the carbon monoxide? Actually, the carbon monoxide itself is useful because this carbon monoxide can actually combine with another a few atoms of the oxides, a few oxide ions, and it can reduce the iron 3 plus into a liquid iron metal. Okay, so this is the essential things that go on inside blast furnaces. So blast furnaces, I just got this picture from Pexels. Again, very, very royalty free picture, but thanks to I don't know how to pronounce your name, I'm very sorry. But yes, thanks to your photos. Yes, okay, it's not, no, this is the paper, hold on. The paper is, I mean, the photo is, the photo is by this person here. I do not know the name, so sorry, but yeah, you got this picture of a blast furnace, and this is what it does. You can see it's a very high temperature process, and it needs, you probably need to mine some very high grade of coal for cooking, or you have to process bitumen or whatever other stuff to provide a source of carbon here. And you see that it's very emission intensive as well. Not the best, not the most environmentally friendly, but how else are we supposed to get iron out? Okay, regardless of what the possibilities are, this is the main process by which, or main chemical reactions by which blast furnaces work. Okay, so what's that got to do with eliminating plastic? Okay, plastic has interesting structure. I mean, it's basically a very long chain of hydrocarbons. So the basic polyethylene structure is repeating units of CH2s. So you have long chain of carbon with hydrogen attached to it, like so. Okay, just doing it very casually, and then you just go on and on and on, maybe extending for 50, 100, thousands of molecules, thousands of carbons long. How many? I don't really know. Okay, but hundreds and thousands, perhaps even more. I don't know a figure, but they're long. The more important thing is that they have this carbon here. This carbon here, as you can see, is a great thing. Well, the thing we like to call it is a reducing agent. It's a great reducing agent to help reduce the iron oxide. Moreover, this hydrogen here, when it's heated to the right temperatures, it can combine with the oxygen here to form water as well. So great. This is very good. Okay. So what's so good about this actually? Well, yeah, what's so good about this? I mean, doesn't it like pollute the environment and stuff? Well, yes and no. Okay. I mean, if you have a bunch of iron ore here, okay, you have a bunch of iron ore here, and you want to process this into steel. Or some other alloys or whatever. Okay, you're gonna have to mine coal out of the ground, right? You're gonna mine coal out of the ground, and you got to employ, I guess, machines to excavate the coal. I don't know how. You have machines to excavate the coal. You need to ship it on trucks. Okay, ship it on trucks. So I'm gonna draw a very poor looking truck here. You got to excavate it, ship it on trucks, bring it, transport it. That's the idea. Okay, you have to mine coal, you have to get bitumen, and no matter what, you're going to be putting out CO2 anyway. Unavoidable by today's processes. Now, what if we just use the plastic within our landfills? What if we just use the plastic within our landfills? Okay, the plastic within our landfills is a good reducing agent for iron ore. And then you can make steel as well. All right, are people actually doing this? Yeah, the answer is yes. Okay, there has been a so-called fair bit of research that has been going on. Here's an article for you. Use of plastic waste in iron and steel industry that can convert waste to wealth. Okay, this looks like it's in South Asia. Oh, yeah. So yeah, that's one advantage. Okay, the plastic's already there. You do not have to mine fresh coal out of the ground just to process the iron ore. You have something that is wasteful here, and then you can use it to smelt iron ore into steel. That's potentially an idea to help reduce plastic waste. Okay, but you might have this concern. Okay, haven't you heard of plastic waste actually forming this thing called dioxin? Okay, doesn't it form dioxin when you burn it? Okay, doesn't it form dioxin when you burn it? Okay, so there, that burning plastic is not an ideal solution because it releases a lot of pollutants. Okay, however, what are dioxins? Okay, dioxins. Okay, dioxin plastic. Okay, it's an unwanted product. So it's an organic compound. Okay. Okay, so one of the formulas, I guess, is 2,3,7,8 tetrachlorodibenzoparadioxin. Okay, I can search this compound out. This is one of the things that are classified as dioxins. Okay, I can go look at Wikipedia. Okay, but what does it have in here? It has a lot of carbon, it has a lot of hydrogen, a lot of chlorine and oxygen. Not a lot of oxygen, but fair bit of oxygen. So here's the chemical formula. Okay, looks like some benzene rings, aromatic benzene rings, and a lot of oxygens and chlorines, which I don't know, make it, yeah, it's like electrophilic, but that's beside the point. Long story short, if you push the temperature high enough, this thing can actually decompose. It can decompose into carbon. It basically, if you hit this thing high enough, it will break the bonds. Okay, well, in conventional plastic fires, I guess, the temperatures are not high enough to destroy this compound. However, when you have a blast furnace kind of a condition, where's this blast furnace condition? Okay, when you have a blast furnace condition, you have temperatures in excess of 1000 degrees C. Okay, this is more than enough to destroy the dioxins. And yeah, it is not just hype. If you actually look at this paper called Utilization and Recycling of End-of-Life Plastics for Sustainable and Clean Industrial Processes under Material Science for Energy Technologies, this is a paper. Okay, I'm not going to try and pronounce the name. Okay, but one good thing about this paper, it is open access. Okay, open access means anyone can view it. You do not need to pay subscription. You do not need to go through your university. You can just read it as such. So this is the article. Okay, so this article actually features this kind of plastic waste utilization for blast furnaces. And if you look at this part, here is a table that says, okay, as compared to using, coal or something like that to reduce the iron oxides into iron, you can use plastics and you actually save some greenhouse gas emissions, right? One of the reasons is, of course, you do not have to use extra fossil fuels to get more fossil fuel or coal to reduce the iron. You can just use the plastic here. Moreover, you saw that plastic actually contains a lot of hydrogen, and that hydrogen also reduces iron oxides to steels. So that will produce water instead of carbon dioxide, which is, of course, a better option in the sense that it reduces the greenhouse gas emissions per ton of steel, I guess. Yeah. So, of course, there are other interesting ways that, they are discussed here for utilization and recycling end-of-life plastics. You can read about it, but the most practical or the most interesting one is where is this? Yeah, it is in this thing here. Oh, where is it? Feedstock recycling in blast furnaces and electric arc furnaces. So if you go to this part, it says thermoplastics find application in blast furnaces used due to the phase transformation, blah blah blah. All right. The more important thing is that in Japan, thermoplastics waste have replaced metallurgical coke, which is this carbon I was talking about before, this coal, carbon, whatever, stuff you mine from the ground, up to 40% in iron and steel making as a reducing agent and fuel. So research has been done before, and it's not just been done on a lab scale. This operation has been done on industrial scales as well, 56,000 tons. That's a lot of plastic. Okay, so Austria and Germany are also injecting waste plastics into BF, which is blast furnaces. So you can see this is a pretty established technology. Now, you might be wondering, so okay, we have oxygen that, just becomes carbon dioxide. You have carbons which become carbon dioxide, of course. And you have hydrogens as well that become water when combined with oxygen. What happens to the chlorine here? If the chlorine combines with some other compounds in the blast furnace, what happens? Well, according to the paper here, you do not really have to worry about this because you see the chemical compositions. Okay, chlorine containing plastics such as polyvinyl chloride can be used in blast furnaces because the hydrogen chloride. So actually the polyvinyl chloride, the chlorine in there actually goes into hydrogen chloride, and then the hydrogen chloride is a gaseous form. It can be actually easily removed by using limestone. Okay, limestone is a alkali or base which actually combines with hydrogen chloride to give you calcium chloride. Calcium chloride, if you dilute it in water, is pretty much harmless. Yeah, you can use it as food additive and all that, so it's not really that much concerning anymore. Okay, so one more thing about this potential dioxin problem, it says that the reducing temperature at the top of the furnace, even at a low temperature, prevents dioxin formation. So actually using plastics in a blast furnace actually helps to not only reduce greenhouse gases as compared to using coking coal, but also it helps to sort out the dioxin problem because the temperatures are so high and the conditions in the blast furnace are reducing, so it prevents this dioxin formation in the first place. Well, blast furnaces, using blast furnaces, plastics as a feedstock to blast furnaces may actually be a pretty feasible idea, and in fact it has been done before, and I think it could be a very practical way to reduce plastic waste, as long as the people can agree with it, as long as there's enough supply of iron ore to actually justify using so much plastic. Okay, so these are some ideas that can be scaled up even more potentially. Of course, you might say, yes, this will reduce greenhouse gas compared to coal. If you use greenhouse gas, I mean, if you use raw coal from the ground to help process iron ore, maybe that's not that environmentally friendly. But if you use the plastics to process this iron ore, aren't you also releasing the gas into the atmosphere? Well, yeah, of course, that is true. You will reduce the amount of CO2 that goes into the atmosphere as compared to coal, but you are ultimately still releasing that carbon dioxide. I mean, there's no free lunch in this world. It's a give or take. But I mean, if you want to consider the cost of leaving plastics with developing countries in Malaysia, there's a social cost there. I don't think it's very I don't know, it's a very environmentally friendly way, and you're just treating certain countries like garbage dumps. Okay, that's in their words, they have said that. And Malaysia and Philippines, they do not want to be treated like garbage dumps for the world's plastic. Right? So you have to find good ways of utilizing this quickly. So this could be an interesting solution, an intermediary solution, where we can use this to reduce the plastic waste presently in our landfill and in our recycling, so that we can reduce CO2 emissions when we make steel in bulk. Until we find a better idea of what to do with plastic, I think this is an effective way of reducing stockpiles. Of course, there'll be CO2 that still comes after that. Of course, there'll still be CO2 that comes after that. What we're gonna do with that? Well, that's a completely different topic for another time. I think I spent enough time, but hope you enjoyed just some food for thought from this reflection video, whatever, yeah. See you guys. See you next time.